If you are struggling with managing your AI tools and making them collaborate between each other, then you are in the right place. In this video, we will discuss about MCP, which is a great way to make tools and give it to your AI agent. And we will also learn how to connect it to our LangGraph AI agents. And at the end of the video, I will show you a real-time project by which you can create many of AI agents using just one technique. So let's get started. So first, we have to see that what is MCP. So MCP is developed by Claude. It is a great way to create tools which you can link with any of the agentic AI frameworks, and you can sort of apply auth on them and access local files with it. There are a lot of ways. So you can find the architecture from the website. If you read that, this will be great. Here I will give a short demo of this. So we will talk shortly about this. So first, what is host? Client, server, tool, and resources. This is the main core of the architecture of MCP. The servers are basically the tools you make, and the host or the client are the things that link you and they call and link with the server. And the tools and resources are the tools you make or to perform any functions, and resources are which you can call and take data from. So basically, we are going to differentiate between them. So what is the difference between tools and resources? So basically, if I tell you where to use them and where to not use them, so I will suggest you to use tools where you want to fetch any type of data or you want API responses and database responses. So there you can use resources. So here we are importing MCP server client from the langchain-mcp-adapter. It is a tool from LangChain from which you can connect MCP to LangGraph or LangChain. Yeah, it's a great help because now we have a pre-built tool which our agent can call to perform functions or get data, and we can connect multi-server MCP clients MCP to our AI agent. It was probably too hard before this package, so now it is easy. So it is pure Python. That's why I created in LangGraph function API. Now we'll walk through the code. So first we defined our entry point and applied a check pointer for memory, short-term memory. Then we have a state in which I only use messages key so that you do not get confused. And here we are also getting previous messages, so the context should remain to our AI agent. Here we are converting messages and getting human message so that we can add it in our you can say state, update our state. Then after that we are defining our client, MCP client. I will show you MCP servers after this, because first we will see the easiest part, which is defining the client, because defining is the easiest part in this. Then we will see MCP servers, and believe me, this is just pure Python. If you have learned Python, then you can do it. We defined here MCP, multi-server MCP client, which will be equal to client. Then this is the update state. Then we will update the client and put some servers in it. So by putting servers in it, I mean that we have to connect servers in it, and these all will be put in a list which is defined in our package that we installed, langchain-mcp-adapter. We can define multi-servers here, but for the initial argument, I only defined one server, which is math server. You can do arithmetics with it. Now we defined a client variable, then we call a function from it, which is connect to server. This is the name by which your server will be called, or the agent will call your server. This is the command that will be used to run the file. I have to show you the file because you will not understand. This is the file. So we have to run it. We will use Python command. You all know we have to use Python command to run any of the Python file. So it is the command we defined here. And this here, it is very important because uh, for MCP to locate your file, you have to provide the path. And by defining path, I mean absolute path. So you can define absolute path by doing this method, that you have from your operating system you have to get your directory name in which your main file is present. Then after defining directory, in this directory we have an MCP folder, we all can see. In this we have a math folder and then the math server.py file. Now this is the absolute path of our math server file. Now as it is defined, now we can move ahead and pass it to our agent. I defined a separate task for it because we have to keep it component based so you can take most out of it. So I defined a call model. In this we will only define our agent, which is Again, from LangGraph pre-built create agent, we just have to provide our model in it and the tools we use, and our agent will be ready. We can invoke it anytime. And in this, we are getting two things in this function. One is messages, the including context. So by including context, I mean the messages that the user is has asked, the question that user has asked from our agent, and the questions that he is asking now. All the questions will be given to this agent, and the client that we defined here. Okay, and connected our servers. We pass that client here in the call model. After that, we created an agent in which we passed our model that we defined here, and the and passed the client.get. Basically, the client.get tool is that you connected the servers to your to your MCP client. Now you can access all the servers as tools because we have defined them as tool and use them by calling get tools function. Okay. Now after that, we will call the agent, invoke it, and pass messages to it. As it already has our tools, whenever we ask him to do any mathematics or ask him to do addition, subtraction, or as many tools that we have in our server, it will call our server and do it by the functions we define, not by doing just doing itself. Now after we get response from our call model function, which is defined here, and we return the response as it is. Now we are adding or updating the messages in our state and then saving the output so that we can access it in the previous in the next messages. Now let's move to the servers that we created. Now we are using MCP via fast MCP, which is a SDK provided by MCP itself, fast MCP. Now we can define server and then use it to create tools. It is as simple as creating client. Now here you have to import fast MCP from MCP and then give it a name. In my case, I defined it as math. You can define it as anything like uh, arth or any arithmetic short form or anything. And then we have to apply a decorator here. The decorator is this. We have to call the tool function so we can create a tool, and our agent will have all these tools so he can perform calculations. And we are running it through VIO, which is standard input and output. It is a way of uh, calling protocols or communication protocols between our servers. We will also make video on SSE, but here we only focused on standard input and output method. So here we defined our tools, and then we have also seen that how we will give it to our agent by defining clients. Now we will see the env. In env you just have to define 4 to 5 things. One is OpenAI key, the langchain API key, which is similar to langsmith API key, the langchain tracking, you want it or not, true or false, and the langchain project name. You can call it anything. I will call it MCP lang tutorial. Now you can name it anything. I have defined my env, so I will move to the next step, which is Docker. If you are in Windows, you will run it in Docker. If you are in Mac, you will run it in langgraph.json, and you do not have to set up all the other things. So here we imported LangGraph API, which is a by which we can run our LangGraph agent, and then defined our directories. And at the last, we defined our server, that where is our service server present, our LangGraph agent present in our directory. Then a more important thing, we also have to define in our project.toml about this in the setup tools and in the package.dir portion. In the packages, we have to define that we have a package named LangGraph MCP tutorial, and in the package directory, we have to define the directory of our package so that it can be identified. If you want to change the name, you have to change here, because this is if you will change the name langchain-mcp tutorial to anything, you have to change here, and also in the compose file here, so that you do not have to build again and again. Now we will run the Docker and test it via Postman. I am using Postman for this for my cursor. You can use it the desktop version also or the web version. All the options are present. Now, as my build is already present, I will only do Docker compose up, and my servers will be created. Containers will be created. Sorry. Now, as we cannot run functional API in our studio, LangGraph Studio, we will run here in Postman. We have to define the thread which we will create from localhost localhost 8123 slash docs. So here our API, all the docs are of our API present. Now we can search for our assistant. Here you can get the key to your assistant. If you run it, you have the assistant ID, which you will put here. This format will be present in the README. You can access it from there. Assistant ID will be placed here, and then the thread ID. Because without a thread, without creating thread, your agent cannot run. So for creating thread, you just have to run this. And for if you forgot the thread ID, you can always search here. I have two thread IDs. I can run it by any of them. I will use my previous which I have pasted here. So we will ask a question to it in the messages portion. In content, we will ask it to add 5 plus 3. The response should be 8, and now we'll get the response. Hopefully it should be 200, and it is 200. We'll pass it in JSON and see the response. It should, and the result of adding 5 and 3 is 8. So now we'll see here that which tools did he call. So we told him to add 5 plus 3. Okay. Now in response to it, he calls a tool named add and passes two arguments a and b, which is 5 and 3 as we expected, and then we have the answer. So it worked just fine. Now we will move to a complex problem other than arithmetics, and it is defining a database. I am using Neon database here because I find it comfortable than running a local and setting it up. For this, you also have to define a Neon DB URL in your env. Neon DB URL. I have already defined it. Now in here we have two files. So first is DB integration and the other is DB server. The main is DB server, but DB integration is as important as DB server because in here all the functions that are used to connect or create or update or delete records are present. So we'll go through them. So the first function in DB integration file is connect to DB. That we defined it in our env, and so we can establish a connection between the serverless Neon DB and our LangGraph agent. So we can put data in it or update or delete records by using the Postgres PySock. Now here we are setting up the connection and returning it, which will be sent to our DB server, so it can identify that whether the connection is created or not. Now, as from the name, it is used to create records in the server. Now, to create records in the server, we have to define a table in our Neon database, which and so that when the agent should search for any of the data tables in our database. So when the agent should search for any of the table in our database related to the topic we asked him to add, it should have that table and the parameters so that he can add it. Now here we have plenty of things. You can read it. I will just go through the function names and what they do. Then the second is read records, which will probably take out all of which will take out all of your data and expose it to our agent so it can perform actions on them. Then the update record, which will update the records. Third is delete record, which will delete any entry that you want to delete. Then the DB server file. So that all were used to help our tools. You can say they were resources. Now we will integrate resources in our tools. So here we will first define our server, then we will define tools. We have create tool, read tool, update, and delete. Basically four tools which are used for any CRUD file or tool. First is create. In this we are calling the create record, which we created here, so that and passing the table and the data. Now by table and the data we mean that it will give the table name to the query so that the valid data can be entered in the valid table. And the data we all know it will go into the columns and then the placeholders, which will be defined by our agent. So it will, you can come in, it will, you can say, provided by agent in a dictionary form, and then the debugging things, and then the other debugging things. Then others are also like read, record, and the others. Now in the main file, which is entry point, we have to make some changes, which is here. We have to connect a server. We will name it database, and we will change the names, because in MCP we have the folder database, in which our DB server file is present, which should be called, not math or math server in math folder. So we will change the things here. These are just logs, but I like creating it in a structured way. So now, as things are set up, we just have to stop the containers and then start them. Now we will go to postman. Now first we will go into to the neon, so that we can create our table, you can say, so that we can pass the queries to our agent. So let's go to the neon. Now I am in the neon console. Here I will create a table, so that we can ask our agent to add entries in it. We will have three columns in it, which is ID, task, and progress. And then we will create. We will name it to do. The schema will be public. Now it is created. The postman and I have updated the form. Let's send it to our agent and see that what he says. So now we have response from our agent. We will pass it in JSON and see what the response is. So it is saying the task has successfully been inserted in our table. So let's see that. So let's see that where the task has been inserted. We are in the neon console, and here our task has been inserted in our table. So so now we have an AI agent that is connected to the database, and which is performing actions, on the queries that we give it to him. Now the assignment for you is to go into the database integration file or DB server, and create or and to go into the DB integration or DB server file, and ask the user first through the AI agent to define the model of its table, and create a table by your AI agent, by not and not by going into the neon database console.